Hey guys, good to see you guys again. We're here at George's shop, and I'm going to kind of pan around a little bit here. There's a bug up on the lift, and he's been working on that. Again, it's almost like deja vu, guys. Seeing George, and you know, from years ago, he had a shop in Riverside, and I helped him a lot of times when I was done with my regular job. So we're going to be starting this engine here. We got the crankshaft in the thing. We had to, this thing, hang on, let me show you this. This, for all these years you had this thing, it was like, and we never had it mounted. Didn't need to, but now we finally mounted it, and then we had to, I don't know, the holes didn't line up because it's pretty old.
Well, it was an 8 dowel.
Yeah.
You know, we don't have the offset pin.
Yeah, it didn't have the offset pin in it, you know, the way that they do now. And so we had to play around with it, got it all mocked up, set up. So now what we're doing is, the first thing we're going to do is we want to remove all of these set screws. They need to be removed, clean out the passages, and then red Loctite them, or some guys blue Loctite. You can do whatever you want and whatever you feel comfortable with. We like to red Loctite usually, and go from there. So these little plugs, we're going to Loctite these in. We're going to clean this all out. There's a lot of cleaning. Off camera, we take everything apart. Everything is clean. So I had a lot of people on my other video say we didn't clean anything. Oh my goodness. No, everything's completely cleaned before we put it together. Even the case here, going to get re-cleaned again before we put it all together. We're just kind of laying stuff out right now, and we're going to do our mock-up so that we can machine this, and then we'll clean it after we done, you know, machine out the areas for the crankshaft. So we're going to be doing that right now. Let's get busy. So we ran, you can run pipe cleaners through here if you want. You can, there's a lot of different ways to clean this. You could also use carb spray and just blow it through, whatever you feel comfortable with. We got them all cleaned out already, so I'm not going to exactly show you everything I'm doing, but you can use your imagination. For you guys who don't know, I'm just going to mention this in this video. George is going to start a new YouTube channel, so stay tuned. Eventually I'll put that link in the description here, and keep on the videos. Make sure you're subscribed, because you'll see that pop up in one of these videos coming up when he gets it rolling. And then he's an amazing, one of the most amazing fabricators, machinist, engine builder that I know, and I basically learned a lot from him. Most of the stuff that I know about engines I learned from the shop, you know. And I'm not as good as they are, so you can imagine he's going to be pretty neat when he gets that going. So stay tuned for that. We got our rods clean, laid out. We got our bearings, and we always clean off this gray stuff that's on here. I'll show you in a second. All right, so this time we're going to choose Scotch-Brite, and we just go like this. Couple swipes, not too much, just a little bit, just to get that stuff off. Some guys use a rag. You can do it however you want. And then we're going to use a rag afterwards and clean the remaining off. But getting this stuff off this surface of the bearing, this ends up in the oil and ends up in the pickup later in the time when you're breaking in.
Don't film anything.
All right, here we go. 2 fingers. I usually do them with a rag, so okay. That one's ready. Let's do this one. Hold like that. 2 fingers in the middle. All right, ready to go. All right, little acetone on the rag. Clean them out really good. See how look at all you get off of there, just from the acetone. Otherwise, that ends up in the oil, ends up in the pickup. Not good. All right, so we're putting in the bearings. If you kind of give them just a little tiny bit of pressure just to even it in, and then push right mainly from my left thumb here, this just holds it in place. You don't want to push from the middle. So, and then I kind of work them, center them in. Again, I was not the engine builder, but I did a few at my house. You know, the shop did them. But he's going to make sure that I do it myself this time. So I've been getting coached here. So I'm not pushing here. Okay, I'm pushing here. I'm just kind of finalizing it like that. And those little bit of scratches that are in there actually will help retain oil. I mean, if your bearing ever touches your crankshaft, it's done. It should always have oil between it and the crankshaft. So, and we're just gonna push it a little bit here and then slide them into place and kind of work them in back and forth all the way in. Okay, do them all and check it out later. So on these, the tangs here, these little tangs go down. The two tangs go together and the rod goes like this. Usually the numbers are up if you have numbers on them. And so what we're going to do is we're going to mark the top side of the rod like here. So the tangs are down, so we just mark right here that that's the top, because these don't have the little marks like the stock ones do. You see the stock ones had a little bump on them.
Cast marking.
Cast marking. They don't have it on the AA short rods or any of the clearance rods. You can see how these have that sticking out. The new ones don't. Just kind of showing you that's why these rods are, and plus the bolts are flatter on this end when they go around. So that's not the case. You got to have the clearance rods for 74. We like to lube the threads and this part right here. So again, guys, we've gone ahead and got these assembled. We got our marks up this way and this one. And then this one would be this direction, right? And then this one goes that way, so we know the place you mark. It's just easier. You can use the numbers too. Just depends on how you want to do it. But I like to put a mark on there just to double check. It's easy to get wrong. And then the two numbers should be together here. So you'll know if it doesn't. See how that moves nice and freely? We're using a different assembly lube than we did on some of the other builds. So it doesn't matter. You can use whatever you want. You can use oil or you can use this stuff here. This is the Ultra Slick Permatex. But as long as once we torque these down, as long as there's no hard spots in them and they're just perfectly evenly feeling all the way around, it should be good to go. So we're going to go with that. So we're torquing down our ARPs going on in the background. I'm not going to show torque specs. You guys can look that up on your own, because if I'm wrong, anyway, you guys do this at your own risk. We're going to just clean our bearings, give them a real quick clean that way. 2 fingers in the middle. And just kind of go swiping back and forth like that. 2 fingers in the.
You know what? I'm getting old.
All right. We're going to clean these after. Guys, we have not cleaned this case totally yet. Just so if you see those metal shavings on there, that's all going to come out of here, because we're just going to assemble the crank clean. Be very careful. Set it in here. Mock it up, and just because we're going to end up opening this up here for the 74. So we'll show you how to do that in a minute, but we set the bearings in, okay, and then mark them. So this might not be the same as the other video that we made, because this is a different builder. So everybody does this different. So there's different ways to learn it. It's really good to learn different ways, so you find out the way you like the best. You know, there's a guy mentioned he had a problem with his dowel pins not lining up. Of course, there's dowel pins in the holes here. So he said his dowel pin, his crankshaft, as soon as he tightened up the halves, it wouldn't seat. So when you put it in, the other thing you can do is look for daylight below here. And you can take a flashlight, hold on the other side, and look through and see if there's any daylight to make sure that the bearings are all the way down in. And then you can pull them back out a few times and make sure those pins are down all the way in the hole, because sometimes they don't go all the way down in there. And when you go tighten the case halves up, it binds. So anyway. Okay, you know, something I want to show you guys is different builders do different things. And some guys port match the bearing to the case. And, you know, we were kind of going over this, and we never did this on new builds, on a rebuilt engine, on a just standard build. This is something kind of came up later. And when the oil goes from the round hole to this groove, okay, it's kind of like a river going into the ocean where it just kind of goes out. So port matching it, I don't even know if it really would help that much. I mean, it just depends on you. If you want to do it, you can put a little bit of paint on here. Okay, you can put a little bit of paint on here. Drop the bearing in place. Okay. If you're doing a race engine, maybe you want to do it just for fun. Drop the bearing in place and then see where it lines up with this groove. It's going to be a little bit off. They're always a little bit off. Okay. And then you just take a little grinder and just kind of help it make a little groove in it. So in my other video, I show that. This one, we're not going to do that way because we are not going to be putting that kind of RPMs at all in this engine at all. This thing is maybe going to hit 4,500 RPMs, you know, on a good day, and that's going to be where it's going to go. So we're not looking to get all that oil, super duper race stuff done. So whether you do that or not, it's up to you. If you ever want to know which direction to put this in, the pin side is to the back. Okay, so if you look here, how the pins offset, and these ones are, well, they're all pins offset to the back. That's how you know that that bearing goes on this way, because that's the back right here, or the front, or however you want to do it. The flywheel side, this goes that way. Favorite method, the hot plate method. My old high school teacher used to use a hot oil. He heated it up with a torch. It was stank and everything. He put them in the oil. So the edge here, the sharp edge goes to this side. And then you see how this is rounded in here. As the other side's rounded, it goes on there. And put this gear on first. Oh, right, your woodruff key has to be all the way in, really even. So take your time and put that in really good. Is it tight enough? Too tight? We're going to use the super knot. Awesome. We don't like to get them too hot, so you take the temper out of the gear. So that's why we use this tool right here. That's been around for years. And then these things should fit really nice and tight, otherwise it can rattle on there. Nice and tight on the thing, like that. A good way to know whether you got everything in correctly is this. If this clip lines up and is straight, you're good to go. If it's in there and it's crooked like this, something's not all the way in. Then just don't even bother trying to put the clip on. So anyway, we'll put the clip on. We're good to go. Let it cool first for us. We don't want to hurt ourselves. So at this point, we're just going ahead and mock it up. And this is just to mock it up to see whether it's clearance. This case was already clearanced. I think I showed you guys earlier in the video, or earlier in another video, but I'll show you what they do. And what you do is you just rotate it around, okay? And you hold the rods as if, you know, you mock it up and hold the rod so that the rod would be where the piston is, right? So the piston's not going to be over here, right? It's going to be right in the middle. So you work it around and, you know, on the other side and on this side so that these don't hit. And then right here, you can see down in there, see if I can get you guys to see. Right down there, it goes by and they're already cut out right there. I don't know if you can see that. I'm trying to get, and kind of do this with it a little bit. It should clear this area. Let's look at the other side of the case. So you can see that's already been cut out right there. That's what you have to do on a 74, is you just clearance that little area, a little bit of grinding right there, like that. Mock it up, see where it hits. Use a Sharpie and cut it away a little bit right here. So it's right here, maybe a little tiny bit of that rib, just a little bit right here, a little bit right here. Again, we're going to mock up both sides of the case so we make sure it doesn't hit. And then we'll proceed to cleaning this. The reason we don't clean it beforehand is because we're going to make metal shavings. We're going to cut all this out, and we're going to do our final cleaning, then we're going to assemble it. So anyway, it looks like this one's already been done. You can see that right there. That little groove is all that needs to be done for a 74. That's really not hard to do. So we remachined these just so you guys can see. It's around the center of this rib here. Around the center of that one. Maybe just you find the top of the opening and do about that. If you want to do it ahead of time, before you mock it up, you can kind of do this. Take that out a little bit right there. Take a little bit out that right there. Here's the other case half. So you got one here, or the center of that rib. So you can see where it is. Center of that rib there, just about. Right here. We just redid it again. It was already done. So this case has already been a 74 once. Weird. Or maybe, I don't know. It was already machined right there. Somebody did it. So anyway, that's how it's done. 74 is ready to go. All right, so we set the crank in, make sure all the dowel pins line up, and then check the center. We're good.
Rods.
No walkies. With the rods up. So we're ready to go on that, but we got to check our cam, insert the cam bearings. Main thing we got to check is the cam, make sure the gear is right. So on the back side of your cam gear, you see that number, -1? They had up to -5 plus 5.
No, 7.
Or plus 7. +5 plus 7. And so a lot of people think maybe if you get an original one, it'll fit right in. Well, maybe, maybe not. If it doesn't fit, you're going to have to drill out these rivets and then step drill here and then put nuts on and thread that guy there. I think, do you thread it or no?
Yes.
You have to thread it, yeah. And do it that way. So better hang on to a bunch of your old cams in case, and then look at them, see the numbers on there and look for the little number in the back. They're all different, and they had to do that because of where it was at in the bore. You know, if the line bore was a little bit different off, then I don't know how it worked out, but anyway, it would make that a little bit off, and so you had to, you want a little bit of play in that gear, just a little bit. Now, if it's too much walkie-talkie in there, it'll be noisy. You'll hear the motor rattling when it's idling, and if it's nice, too tight, and then you'll wear your bearings out. So you got to get it just right, the feel of it. Like this one here is +2. You can see that. And all it is just a stock gear. And
then we drill out the rivets, but then we have to countersink that.
We have a countersink that goes in there a bit. That was in the back shop. I remember you showed it to me.
Like
oh, that's what you use there. So that type of thing there. Used to make them.
So that's so the bolt head will clear the pump.
Ah, yeah. Otherwise, if you just put bolts on there, yeah, it'll hit the oil pump. That's for sure. All right, so we were going to set the cam bearings, and I noticed one thing that I might have not shown in another video. There's a tang on here, and there's no tang on this side of the case because it's a double thrust bearing. So you can see this side has the tang in it still. So this one here is where the one with the tang goes. And what we do is take a bench grinder and just grind that guy off for the other side. If you want to make sure that thing's gone, you know, so it fits in the case. Again, this is all the way we do it. You guys can do it however you want. This is not a how-to video. This is just how we do it. And, you know, you can take it or leave it and do it your own way. It's not, we're not doing that. We're just doing, this is us building a motor. So we got the cam in. We got just, if you can hear it, it's really, there's a little bit of play in different areas of it. Got to rotate it around a few times. You can hear that little tiny bit of rattle. So this one's really nice and tight, but it's not over tight. So let's see. You don't want it to, if it's too tight, when I turn it, this thing will walk out, okay? So it's not doing that. And I got a little tiny bit of play. Just, you can hear that. You can hear that? So that's actually good. So we're gonna go with that. If it's really, really rattly, then it's too loose. You might have to change the cam gear to whatever, a +1. Is it plus or -1? -1. If
you already got -1 in there. You go 0 plus, and it goes
Yeah.
up to plus 7, and then it goes 0 to minus 7.
Yeah.
So there's 15 different combos.
Wow. So anyway, if it's really loose, if it's really rattly, you'll hear it when it's running and it doesn't sound good. So it's got to be a little tiny bit of play. Just barely can feel it. And then we've rotated around a few times and it seems to be okay. Like watch a rivet and move it around, watch another rivet, and just check it a few places.
Oh, mother.
And the little bit that's there will kind of wear in. All right, so we're in time, guys. We're good. All right, so our O-rings are on. We'll put those down. We got the oil pump. We like to put it on and just make sure that it's going to clear. And we've already rotated this around, put the rivets next to it. It's plenty of distance in there. You just got to check it. Sometimes if you got a 30 or something like that, it may not work. You know, may hit the. You have to grind the back and side of that sucker off. This part right here. And get that thing out of there without dropping the gears out. All right there. Yeah. Right there. Good hit right there. You're going to have a problem with a dish cam, you know, the later model. These flat ones usually don't have an issue, but just check it. Never hurts. And this end's already plugged here. We checked the case. It's nice and tight. This was really good. Some guys will say you plug both of them. I think that's really like an aluminum case. I've seen the aluminum cases are a lot looser than the stock ones, so we're not going to bother plugging both of them for the full flow on this. It really doesn't make any sense on one that's perfectly tight. Yeah, so we're putting on, we like to use the Yamaha Bond or Honda Bond, whatever one of those for the case halves.
Number 4.
Yeah, you can use the Permatex if you want, but that's kind of the old way. We came up with this idea a long time ago, and everybody kind of likes it. So if you put the stuff on this side of the case versus putting it on this side, you don't have to go around the studs. So a little trick there, guys, if you didn't know that one. Then we got to put don't forget this thing. If you do, you're taking it back apart. But yeah, make sure it's the right one too. There's a 40 horse one that's smaller and a 36 horse. I don't know if the 36 horse and the 40 are the same, but I know that 40 horse one's different. So we got to make sure we get our cam plug in. And our lifters are oiled. Our mark is right. Timing mark, double check it. Can't hurt to do it twice. Make sure all the O-rings are on. Everything's there, and then put the case half on. Process was really fun. It was really nice to hang out with George. I don't really get much chance to do that anymore. I hadn't seen George in a long time, and we just run into each other places. And then finally, when he retired, and I had a little more time, you know, there was never time, you know. So it was great to be able to be there. His shop's kind of new. He just put this up, and he's still moving stuff into it. There's like tons of buildings out there with just amazing stuff in them. I couldn't even tell you guys what's in there, but you know, some of the stuff was kept from the shop. I thought all of it was gone, but you know, he did keep a lot of the good stuff, and managed to do that through, I don't know, all the different difficulties of life that happened between, you know, the late 90s and now. So anyway, it was really kind of fun there, hanging out, you know, just be able to do our thing, and brings back old times, let me tell you. It's really fun. As a practice, see how that's at there? You make sure it's in there deep enough when you push it in. So then you turn it, it goes in. So it's in there about 3/16 of an inch, so that should be fine. Always want to make sure you got enough bite in there. So I've seen people put like grease on their oil pumps. You know, really, I wouldn't recommend doing that because or anything. Really, all you need is like 2 drops of oil on there, just enough to crank the engine over until the oil pump primes. If you put anything else in there, it's going to end up in your oil galleries, and eventually, it could clog something. So it's best just to put 2 drops of oil, let the oil pump prime, and then what we do is we take the coil wire off, crank the engine over after you're done putting the engine together with oil in it, and let it run through all the galleries and prime up, and turn the engine oil light off, or usually I have a gauge on it and I'll watch it and make sure it goes up to 40 pounds or better or something. And then go ahead and continue on. And the oil did its job, not any other kinds of additives or anything. A lot of times you'll use studs on these, but this needs to go on either. We used to use Gasca cinch. It was like a contact cement on these, but we don't have any, so this goes on either dry or with a really, really almost nothing adhesive. And nothing on there. That's a metered gasket right there. So make sure it doesn't fold. Put it on, we're good. So what we've done now is we've stripped all the pistons down, and then got them all just raw piston here. Got all the rings off. I do my rings, I take one groove off, I take the top one off, they take the middle one, I put it in the second groove over, and then I take it off that way so that I don't break them. And then the oil rings usually not a problem. I just take one off, take them off in 3 pieces, no problem. All right, so we just take the micrometer. We have it set at 200 thousandths. That's what we figured out. I don't know, if I were going to do a 74, or if you did short rods or long rods or whatever, I'd still cut them. I don't know, or at least check them. But we figured 200 thousandths is what we needed to take off. So that's what we found out.
We started off at 120 and we added another 75, and that's what.
We started off with a 125, and it still hit.
Yeah.
So then we went to like 175, and we didn't feel comfortable. It was still too close, so we went to 200. Now we got plenty of clearance, so that's where we're at. You can do whatever you think is right, but that's where we're thinking we're at. So we describe them like that
with a caliper,
and then we use the caliper, of course. You use the caliper, just lock it in. You lock the caliper at 200 thousandths, do them all the same. And we mocked it up here and made sure that, and we do that with the thing here. And you could use a cutoff wheel, or not a cutoff wheel, but a grinder with like a flap wheel or something, and just very slowly. Don't try and do too much at a time. Just go right up to your line. That's the way a lot of guys do it. We got this fancy machine, you guys. So. If you look right there, you can just barely see the line. So we took it right up to the line and did them all the same. Then we're going to weigh them, make sure they're all the same. But I've had other guys that said they weighed them afterwards, and there was no change in variance between them. So we'll check that and get back to you guys. Look at this. So we got done doing them all. I mean, all you got to do is, however you want to get it to that line perfectly, you can sit there with a file and do it, whatever. I would suggest if you're going to use the flap wheel that you'd want it going this direction, not too much going that way with a heavy grit or anything, or use a finer grit. Just take your time. But look, 428. What's that one? 428. 428. 428. Now watch. That's just a piece of paper.
Oops. Didn't do it that time.
No, it didn't do it that time. You did. Yeah, 436.
432.
432 with a piece of paper on it. So that's how accurate you can do it by just using that scribe method. You can measure them if you want, but you should have a gram scale and check it just to make sure. But anyway, that's a little.
And if you need to take it off, you can take it off down inside of here.
You can take it off right in there, one of those little ribs or something.
Yeah, in between that little dot or whatever, just anywhere in that area. Right
there. A little dot, the ribs or something.
Drill press and
little tiny bit.
A little bit.
You can only take a little tiny bit. That's going to be it. Anyway, that's how you do it. If you were going to do it yourself, and that's how we do it. You guys can follow our way to do it. You can not do it. You can take it to a machine shop, have them do it. It's up to you completely. It's, you know, your engine. So anyway, that's how we do it. And look at that. Perfect. All right, I wanted to talk to you guys about the benefits of going stroker. Really, unless you really just want to save $100, you know, that's really all you're looking at. If you're going to do a counterweighted 1600, you're not going to save much by doing that, and you'll get a lot more power with a 74. You'll have a 4140 crank, 4340, one of the two, whatever you do. You end up with a better engine. Because the parts are just cheaper now for doing stroker versus doing the 1600. They're just, I mean, they're not cheaper, but it's just worth it, believe me. So these are copper. And so what you can do is a lot of different things you can do when you go stroker because you've got more options. All right, so you could do this engine with the 5325 rods that we're doing the same thing. And what I ended up with was we checked our deck height just with a raw piston. We're putting the rings on right now, and it was at 35 thousandths. Now, you know, on a normal engine, that would be a little too tight. You know, if you went to 35 thousandths, you know, it's doable, but you got to step cut your head, and you have to run copper gaskets and stuff like that. But you won't end up with a deck height that low usually on a regular 1600. You're usually going to end up at around 50 or 60, somewhere in there, and then that's perfect. You can't, you know, make your deck height lower, and not unless you have your cylinders machined or something like that. So our deck height was 35. So to make the compression lower, because I want this thing to run like a tractor, we're going with copper shims on the top. Okay, so what's the benefit of that? And look, this is why, because I can put this cylinder in here, and you can see I had them cut it for 94, so there's no edge of a cylinder, so I could run these up to 0. I could run a flat deck height with this setup, okay, because I got them open for 94s, okay, or 92. These are open for 92 because they don't have a machine for 88s. So the piston, even if it was up all the way, it would still be whatever the thickness of that is, which are probably about 80 thousandths, looks like to me, from the head. So even running them at 0 with no copper shims would be fine on this setup. So there's a lot more options when you have stroker, because you can have, let's say I got 5.4 rods instead of 5.325s. That's 100 thousandths more taller, or 94 or something, I don't know, but near 100 thousandths more piston height. Then I say I could run 60,000 shims or whatever on the barrels and bring it up to where I have the piston right at the top of the cylinder like every other engine usually is made. Okay, then you can step cut your heads like here. You see how I'm step cutting? That's what a step cut is. Let's get you up close so you can see that little step in there. I have them step cut the heads. Now I can get all the fire in the barrel. That lowers your chance of getting detonation with a lower compression ratio, with a higher compression ratio. So you could run higher compression. We could even run this at 8.6, where it would be, you know, when I ran the numbers on the CB performance calculator, it came out to 8.6 to 1 without these copper shims. But with these copper shims in it, it comes out to 7.9. Let's just say 8, okay, which is above stock. Stock is 7.5. All right. So if I run these, I literally could. This thing's gonna be like a tractor, and that's what we want with this engine. Okay. But if you didn't want that, you wanted performance, you could run it like that, and then do the 5.4 rods and run it straight to 0, and then you could get up to about 9 or something like that, and 8 3/4 to 9 to 1 by running it at 0, and you have all your fire in the head, less chance of detonation. I'm just saying, you think about this, there's a lot of options that you can do when you do a 74 that you can't do when you do a 69. And you know, it's like I said, it's about $100 difference in price, because you have to buy the clearance rods. Okay, that's really all it is. CB Performance rods has those 5.4s, stock size rods. The one we're running is 5.325. So, and the reason I'm doing that, I would go with the 5.4s, but the reason I'm doing the 5.325s is I didn't want the engine to be too wide, because the bucket truck has had a 40 horse in it, and my metalwork was a little bit off. Okay, it was about, you know, let's say 1/8 of an inch off, right? So when I put the engine in, it's really tight on the left side. So if I make an engine, you know, a 1600 or 74 or whatever is wider than a 40 horse, right? So if I actually put more shims in there in addition to that, now I'm going to add even more width to it. And I didn't want to do that. So, but in your bug or whatever, you can play with this a lot. You can do so much stuff by going. You could go by going to 74. You can get your deck height to 0 with these 88s, no problem. You know, put it up, mock it up, look in there, and make sure that there's no edge sticking out from this, right? Or you can just run. They have these in 40 and 60, and put these in the top and run. What most cars do is they have a head gasket, which is that's what this is, right? They have a head gasket, and what that does is it gives you all your fire in the combustion chamber, which is more efficient, which is less chance of detonation. So those are things to think about that you can do with a 74 that you cannot do with a 1600. So anyway, I could see somebody taking an 88 by 74 and making something really pretty fast. I mean, I think you could probably get at least 100 horsepower out of it. And I'll tell you, 100 horsepower in a bug is fun. It is fun. It's like a 350 V8 with a cam and a Camaro. Fun. All right. So you want to go really, some guys say, oh, you got to go 2332 to be fast, and you got to have a bigger. You don't really. You can have a whole lot of fun with an 1800, and especially when you do this kind of thing and you bump the compression up, you get it up to like 9 to 1 or 9.5 even, or something like that, by playing with putting all the fire in the head. Just food for thought, guys. I'm just telling you, you know, it's not hard to machine these pistons. You saw that. It's really pretty easy. No brainer. They all measured the same weight. So a lot of things you can do when you just go to that stroker, and it's really not that hard. Just make sure you mock up that case Because if you run their rods, the bolts might be different. I don't know on the CB Performance. So they might bump. You might have to do a little bit more work on there. So you've got to mock it up and check it, okay? But it's not hard. Anybody can do it. If you can build a 1600, you can build a stroker 74, pretty much. All right, talk to you guys a bit later. Got all the studs in with blue Loctite. Well, sometimes when you don't know where your ring compressor is, I should have drug mine out, but these things kind of work. It's terrible. But anyway, ordered a new one. A good Volkswagen one. So we're doing them like this. You mock them up like that. The arrow's going back. And you just push your wrist pin in. Put it in place. Set the rings. The top, 10 and 2. Never set the ring gap on the bottom. Sometimes the oil coagulates on the bottom, and when it settles and sits there, it'll go up the cylinder and leak into the compression and start up, and you'll get a little puff of oil. So we do them that way, 10 and 2. Drop them in. Talk to you guys later. Arrows to the back. Flywheel side, actually. The front, actually, if you guys want to get technical, but you know what I mean. Front's the back of the engine. That's a real torque wrench. Yep, there it is. Torque the flywheel.
Let's go to 250.
Makes me feel better at 250 too. That's the old school way we did it. I bet it doesn't even move, hardly. Nope. 230 and 250, no change. Cool. That's the old torque wrench from the shop we had. All right, well, a couple things we didn't show in the video. I wanted to kind of go over them now. One of the things I forgot to mention is when you put your lifters in, of course, your oil, and then of course, you know, the sides of them and where it contacts the cam, really important. And then they need to spin. If they don't spin freely, if there's hard spots in them when you spin them around, that's going to be an issue. You're going to have a worn out cam very quickly. Seen that before many times. Lifters need to spin when you put them in. Another thing is again, we put this is type 3 cooling system. A lot of people say it doesn't work. If you see these deflectors here, helps bring more air around the head, okay? And our main thing with this is meter what we're putting over the cylinders. We want to get as limited air as we can over the cylinders and have lots more air on the heads, because of course now we've got all of our combustion going on in the head pretty much. There's, you know, 35,000 deck height is really tight. I mean, again, you can go to 0 if you know, you can play around with the 74. You can get the 4 rods, and then, you know, you'll have a shim here, and you'll have the, you know, all the fire in the head if you do the step cut and or the head gasket. You can just use the head gaskets at 60. Some guys do that, and the 60,000s head gaskets, you can do that too. So, and not step cut it. So it's up to you. There's a lot of options you can do when you use those head gaskets, especially with an 88, because you've got such a, you know, you're going to have, they only make a 92 head gasket. So either 90.5s or 92 all use the same head gasket. So they'll be way far away from the piston. It's, you know, it works out really nice to have those head gaskets and use it that way. So you can run a really tight tolerance. You can't do that with a 1600 because the barrels, it just doesn't work out. The numbers don't work out. The other thing is, again, we put the cool tin on. I put the heads on off camera. We had a little bit of a trouble. We had to stop and start again, stop and start again, because, again, this was not an engine that I took apart. This case is different. I didn't have all the stuff that matches up with the case. We had to find head studs, you know, all kinds of stuff. I brought a bunch of 1500 ones. We did that. We had to look for those. So it was a little bit of a goose chase in there. Did find some cool parts, the two little shop tools that he had when we were looking around George's shop. Again, this engine is not running a cooler in the fan shroud. We're going to run all of our cooler outside the fan shroud. No, I will not put it over the fan inlet. That is a no-no. That makes it run hotter than stock. But what this is going to do is, because I want it to look like the original engine, typically I'll use the doghouse fan shroud to get the maximum cooling. But we can't do that because I have to run the original fan shroud on this engine to be able to get the air cleaner, the stock air cleaner to mount up properly. All that stuff matters. So I want this engine to look original, like the 40 horse that was in it, because it's going in the bucket truck, which is this thing here, which is a original Volkswagen product. It's actually a SO10, the special model. There's probably only 2 dozen of them left in the world, probably. But anyway, that is split window ones. There's some bay window ones out there, but split window ones, very rare. They always rusted out. You know, the treasure chest area would just be wasted, kill the whole thing. And they're not allowed to drive them in Europe anymore, so you have to get it certified. The lift has to be certified over there to be able to just even drive the truck. I don't know all their rules, but anyway, some guys have just told me these things, so maybe they're right, maybe they're wrong. Second-hand information. So the rocker arms, again, when we just slide the push rods in, give them a little oil on the ends. Same thing, you know, a lot of stuff is going to get oil as soon as that engine cranks over enough. It's going to go over, I don't know how many revolutions before the oil gets on everything. And again, when I put the oil pump on, I put 2 drops of oil, one on each gear, and I put a little bit on the end of that shaft and a little bit on the shaft itself. You know, just a little tiny drop of oil on each piece. That's it. And just enough to get it so that when it spins over. I did notice in the section when I was running the cam around, okay, it almost looked like the cam jumped out, but it didn't. What it was is the oil we were using is, you know, I've used a lot of times, I've done it with motor oil. You know, this is George's way to do it. He likes to use that stuff, so we're doing it that way when we're at his shop. So whichever way, everybody's way usually works fine. You can use motor oil to assemble your parts. If you use motor oil to assemble your parts, or if you use, I used to use motor oil and STP mixed together. Everybody has their different way to do it. It will turn over easier, and that oil is very, very sticky. It's actually really good for an assembly because it stays on the bearings and all that until that oil comes through. It really gives it a good lubrication for those first few revolutions until it turns over. And you'll find that, you know, that's kind of sticky though when you turn it around. So I was pushing the rods and I pushed the crankshaft up out of position. So that was what happened there. It was actually the crankshaft that kind of moved up, not the cam. And I actually had to reset the bearings too, because George looks at it and he goes, "Hey, your crank's out of place." And I'm like, "Oh shoot, I wonder how I did that." And it was actually, I could see it in the video where I actually pulled the rods, because I was using the rods to turn it around, because it's very stiff with that oil. It turns freely, but it's very stiff. So it's just the type of oil it is anyway. So again, you can use whatever oil you like to use to do your assembly. It's up to you. In the next video, I'll be doing the assembly of the tin and all that stuff. I might have to do some modifications. I'm not sure if I'm going to have to put a breather system. I might run it without it and see if it works. If it doesn't, then I'll put a breather system on it at that point. It might with a 74, because it has those big counterweights going around, and like to cause like a fan inside that engine. So I'll probably have to do something to modify the breather system. So I'll do that later in the other videos. Again, this thing's set up like a tractor. We're not going for RPMs. We're going for really low torque stuff. And it's, you know, that's basically all it's going to do. So yeah, I could feel that play in the cam, but when I was trying to film it, of course, it didn't want to do that. It's probably because when I was cranking it around, even before I did the video, I pulled the crankshaft out of place. But when I got it down in there, it gives you a little tiny bit of play, which tells me everything's okay. Again, before putting the two case halves on, I don't know if I showed it, but I dropped this bearing in the center main, dropped it over the top to make sure it didn't rock, and it didn't. So that was when I know that we had everything in place. And of course, when I tightened up the two case halves together, it still rotated freely, so that wasn't an issue there. Again, I didn't show that because unfortunately there's a lot of distractions because we had to stop and get parts and go look around for stuff, and you know, just a lot of things like that that happened during the time when we were making it. So you know, we ran into some issues, like I said, putting the heads on. We just if you're gonna buy the hardware kits for the heads, I really would not recommend using the head bolts that they give you with those. I really wasn't happy with these head nuts. These were okay, but the head nuts, I would not use them. Take your original ones if you have them. Unfortunately, I didn't bring any with me because I had trouble getting my parts clean. Need a basket to put them in my sonic cleaner. So anyway, I haven't done that yet. I'm still looking. I have a basket somewhere and I can't find it. So anyway, just a couple things I wanted to go over again. When we do the rest of the video on the engine, you'll see some more things coming up. But really, honestly, you guys, I don't think I'll ever put another $1,600 together unless I have like a good crank that I get for free, or a cheap crankshaft, and I've got some used rods or something like that I can just use because I've got them laying around. Otherwise, if I'm going to buy new parts and I'm going to build a new engine, it's going to be at least a 74, because it just is so nice to be able to do some of the mods you want to do, like shim the heads instead of shimming the barrels, you know, using the head gaskets. You know, there's just so many more options that you can do by giving the barrel a different place in the engine and trying to get the fire in the head. That's always something we always wanted to do back in the old days. But back in the old days, when you built a 74, it was you might as well build a 78. You know, it was like or 82 or something, because it was so much money. You had to buy, like, the rod options were really limited. I think all we could get, well, there was like either you could get Volkswagen rods clearance, which was not cheap to do, and it took some of the strength out of them and stuff, or you could get Carrillo rods. There wasn't these other rod companies that we have now, like, you know, the AA and CB makes them, so, you know, makes the clearance rods. So the options were really, really expensive. I mean, Carrillo rods back in that day were like $400. So if you had Carrillo rods and a $250 crankshaft back then, they were about $250 for an Acrasa. So you had to literally spend almost, you know, what was that? $600 when the whole engine kit was $150 to $300. It was a lot more money to go to a stroker. So that's why everybody built 1776s, because you could just, you know, a stock crankshaft, I think they were $30 or something like that. It was crazy cheap. So there was no reason to go to stroker stuff unless you just wanted to spend a lot of money. Well, nowadays, what's a stock reground crank run? I don't even know. What's a stock set of rods resized run? By the time you spend for those two items, and you've still got a crappy stock crank, which is not nearly as good as a counterweighted crank. So if you got a counterweighted crank, they're the same price for a 69 as it is for a 74. And then all you can run with the 69, you can run the stock rods, but you got to get them resized, right? So you're really almost exactly at the same price doing a 69 as a 74. So it does not make, to me, any sense to do a 69 anymore. It just doesn't. So if you go 74, okay, to a 74, you get the clearance rods. You can go to the 5.4s, you can go to the 5.325s, you can go to the 5.5s and go B pistons. It depends on what you're trying to do. But, you just have to do your calculations. Remember, the theoretical difference, and it's not always the same, is exactly what you measure, okay? Theoretically, it's not always the same. Theoretical difference is you got 2.5 millimeters each direction on your stroke. All right, 2.5 millimeters. It's 5 millimeters difference. So it's 2.5 this way, 2.5 that way. So all you're adding is 2.5 millimeters here. So if you're going to add it between the cylinders, you can do it there. You can take it away by doing the shorter rods, the 5.325 rods. That's what we did on this one, so that we don't have too wide of an engine. You can go with the stock rods, okay? With stock length rods, you can't use stock rods with it, but you can use stock length rods, and then you'll have to shim here, and you can shim here and then step cut your heads so that you can run your deck height up to 0 or 5, whatever you want it. You can make it almost 0, whatever. And then have all your fire in your head, which would improve your performance. There's a ton of options when you go a little bit of stroke. The only difference is, remember, you saw that little bit of machine work on the case. If you go right at where those ribs were, the top ribs that go right between the cylinders, you're going to be pretty close. You could probably just machine it out right there like I did before we put it, actually somebody else did before we put it together, okay, and then put it together and then check it. It's probably going to be okay. And then go ahead and do the build. It's really a cool way to build an engine. There's just, to me, the 69 is a dead crankshaft. To me, it's like, why? There's no reason. Anyway, let me know your comments on that. I'll talk to you in the next video. Please like, share, and subscribe. Hopefully I didn't go on too long at the end here.